Today we're going to talk about section 4.2, the operations with functions. We're going to add and subtract and multiply and divide functions, and we're going to find out how to do compositions of functions. The biggest thing you need to remember is that when we have adding and subtracting, you can only combine like terms. So don't forget that. If we have two functions, let's say we have f of x is x squared plus 2x, and g of x is 1 over x. And I must put another one in there just to make it easier. We've got h of x is 5x minus 3. Well, if we write this f g of x, what that means is we want to multiply f of x times g of x. So we write out f of x and we multiply it times g of x. And once we multiply that all the way through, we end up with x plus 2. Now let's say we write f plus h of x. What that means is we want to add the functions f of x plus h of x. So we have f of x is x squared plus 2x, and h of x is 5x minus 3. Now we simplify that by adding like terms. The only terms that there are more than one of is the linear term with the x. So we add those together and we get x squared plus 7x minus 3. That's as simplified as we can get it. If we write f of x divided by h of x, then what we're doing is taking x squared plus 2x and dividing it by 5x minus 3. We've done this several times with long division. 5x minus 3 is going into x squared plus 2x. So what do we have to multiply here? Well, we have to multiply this times 1/5 x, which gives us our x squared, and then minus 3/5 x. So we're subtracting this, which changes the signs there. Those cancel out, and we have 2 3/5 x here. So what do we multiply 5 by to get 2 3/5? Well, it's 13/25. If we multiply 5 times 13/25, that gives us 13/5, which is the 2 3/5 here. Don't forget all those fraction rules. And then, of course, we multiply the 3 times that as well. Then we subtract, those cancel, and we're left with 39 over 25. So our answer for this is 1/5 x plus 13 over 25. And then you can either write remainder 39 over 25 or add it onto the end here in fraction form. So that's multiplying some and adding some. Let's try, if we go back, still using those same functions. If we have f of x times h of x, it's a little more complicated than what we did before. And sometimes you used FOIL probably in Algebra 2. You can use that. It works. It's the same thing. I prefer to use methods that are just like with numbers. And we've done this in class some. So you stack them up on top of each other like this, just like we would with regular multiplication problem with numbers. And we start with this term here and multiply it times everything. So we get negative 6x and negative 3x squared. And then we multiply this term by everything, and we just line up the ones that are alike. So 5x times 2x gives us 10x squared. So since it's an x squared term, we put it under that x squared term. It's positive. Then we have 5x times x squared, which gives us 5x cubed. Add it all together, and we get 5x cubed plus 7x squared minus 6x. And that's the product of those two functions. Let's try one more. Let's do f of x minus h of x. The biggest thing when you're subtracting is you've got to make sure you remember that you're subtracting the whole thing. So that means this minus sign is going to get distributed to the whole thing. So it's going to change the signs. So we're going to end up with minus 5x and plus 3. Don't forget to distribute that minus sign. And then there's our answer. So adding, subtracting, multiplying, and dividing, pretty basic, pretty much stuff you've done before. But we're going to add something to that. We're going to add a composite function. A composite function is when you put one function into another. So, for example, if I write it this way, this means that I'm taking f of h of x. What this is remember, this is our input. So we're inputting the whole function of h of x into our f. So we take our f, remember our f of x is x squared plus 2x, and our h of x is 5x minus 3. So we're taking this whole 5x minus 3 and putting it in here and here for x. So our input values are now 5x minus 3, so that's this part here, so it's squared, plus 2 times 5x minus 3. So we just took this h of x and inputted it in for x in the f, just like if we had a number. So then we can simplify this out. Multiply this, 25x squared minus 30x plus 9 plus 10x minus 6. And then combine your like terms. There's only one squared, so it stays the same. Combine the two x, the linear terms, and then combine the constants, so that we end up with 25x squared minus 20x plus 3. So let's try another composite. What if we have f of g of x? Okay, this is using the second one is the one that you're inputting into the first one. So we take our g, remember f of x is x squared plus 2x, and g of x is 1 over x. So we're taking our g of x and putting it in for x here. So we have 1 over x squared plus 2 times 1 over x. You can simplify this and get 1 over x squared plus 2 over x. Get a common denominator by multiplying this by x over x. So we end up with 1 plus 2x all over x squared. Now sometimes you're going to take composites and you're going to use more than one. So let's say, remember our h of x is 5x minus 3. So let's look at this. What if we take g of h of f of x? What is that asking us? Well, what it's saying is we're going to take f and put it into h, and then we're going to take whatever we get for that and put it into g. So let's come up here to the top and figure out what h of f of x is. So our h of x only has one variable spot, so that's where we're going to put in the f values. So our f is x squared plus 2x, so we'll multiply that times 5, and that'll give us h of f of x. So h of f of x is 5 times x squared plus 2x minus 3. So 5x squared plus 10x minus 3. That's our h of f of x. So this is the part here that we're going to input into G. So we end up with 1 over 5x squared plus 10x minus 3. And that's all there is to it for a composite. Just make sure you pay attention. Start at the inside, input it into the next one, then take whatever you get from that and input it into the next one. Make sure you've read section 4.2 and looked over that, taking good notes both from this lecture and from the book, because they'll be checked next class period.